Simple harmonic motion. We're going to start by looking at a mass on a spring oscillating vertically. So we did this in class. And just like we did in class, we're going to use a combination of pictures and words to figure out what's going on. We're going to start with a free body diagram. And we're going to do this at various stages of the process. So this mass is going to oscillate vertically. So gravity's pulling down, and when we're at the top of the oscillation, the spring is actually going to be pulling downward, all right? Because a spring always wants to go back to its happy place, its equilibrium. And if I've displaced the mass towards the top, it wants to pull down. All right, so what about at that middle point on the way down? Well, at the middle, the mass itself is at equilibrium. So that means if the weight is down, it must be counteracted by the spring force upwards. Okay, so let's look at the bottom of the trajectory now. Again, weight is downward, but now the spring force is pulling up, and it's going to be bigger than the weight. It's going to win out. And then again, at the middle, but on the way back up, we're again at equilibrium. So we're going to have two forces, the weight downward and the spring force upwards. So, fair enough, we've got 4 free body diagrams. So the next thing we're going to look at is the acceleration at each point. Because going from Newton's second law, we don't know the mass, but we can at least figure out the direction of the acceleration for each one. At the top, it's accelerating downward. At the middle, it's equilibrium, so there's no acceleration. The bottom, it's accelerating upwards, and again, at the middle, no acceleration. Between the acceleration and looking at the actual physical motion, we can figure out what the velocity is. At the top, it's changing direction, so it's 0. Going down, it's some negative value. At the bottom, it's changing direction, so it's 0. And at the middle, going up, it's some positive value. So, again, just like we did in class, we're going to put these on a graph. And now we actually have the graph directly underneath the free body diagrams. So, we're going to plot position first, which is what we could actually physically observe in class. So at the top, it's some positive value. We're going to call the middle our equilibrium, our 0 point. And then there's the bottom and the middle, and then it would go back up to the top at some point. And I'm going to very crudely connect these lines. All right. And so we get some sort of sinusoidal graph. This is not perfectly to scale, but you get the idea. So that's position as a function of time. All right, next we're going to plot the velocity. And we're going to put this in blue to match how we wrote this. So at the top it's 0, and then negative, and then 0, and then it is positive, and then it's going to go back to 0 to complete the cycle. And again, we're going to connect these, and it's still a sinusoidal graph. Again, not to scale, nor perfectly drawn. But you get the idea, that's your velocity as a function of time. And finally, we're going to plot our acceleration. So then it's negative, and then it's 0, and then it's positive at the bottom, and at the middle it's 0, and then if we completed it again back to the top, it would be a negative acceleration. So, we have 3 graphs, all sinusoidal, and so essentially we get this periodic process that keeps going back and forth.